Hi guys and welcome back. So here we have an HP laptop for repair. So this is a different case actually. So this board is working fine. So once we press the power button, it is turning on, but we are getting a white display on the screen. So it looks like a tube light. So there's no images on the screen. However, I found the problem immediately once I take off the motherboard, just connected the display cable and triggered the power button using the tweezer, and I got the display with the backlight. I got the images with the backlight. So there's no problem. So what is happening with the power button board on this side here? So can you guess what would be the problem? So what is there on the power button board except the power button? Can you guess it? Yes, it's the lead switch, or it's a Hall transistor. So there's a Hall transistor or Hall sensor on this point here on the power button. So once you close the laptop, so there's a magnet on the A panel or B panel. So once that magnet come closer to the Hall sensor, it will create a magnetic field. Through that, the Hall transistor will pull the lid out from the VCC to ground, and at that time then your EC chip will understand that your laptop has been closed. So based on that, it will do some works to take your to turn off the display and also to take the computer into a sleep mode. So based on that, it will take some steps. So what would happen if the lead switch fails? So this would be some reason. So getting a white display, or sometimes your laptop even won't turn on. So I have never seen a problem like this one here when a lead switch fails. I have seen the motherboard would not turn on if the lead switch fails, but the first time I am seeing that there's no backlight. I mean, there's a backlight, but we don't have a picture. Before that, I have seen on some other laptops, we got the display, but we will not get a backlight because the lead switch was 0 volt, which is pulled to ground. So on that case, the EC chip will not release the backlight on signal. On that case, we will get only an images. So like a shading of images, we can't see anything. But on this case, it is opposite. So we are getting a backlight, but no images. So I don't know how the EC chip or the CPU understands that the lid is closed. So EC chip has to inform it. So okay, so let us go through the schematics and understand how the EC chip tells the CPU that the lid has been closed. Based on that only, the CPU turns off the video signals to the display port or the LVDS. So through that, we are not getting a display, only the backlight. Okay, so now I will show you the readings on the power button connector here to understand what is actually there. Okay, so this is pin number 1 on this side. So pin number 1 is 3.3 volt LDO voltage, which powers the power button board. And on pin number 2 we have the lead switch signal, and also on pin 3 we have the power button signal, and pin 4 is ground. So let me check one by one. Okay, right, checking the first pin. Okay, so the laptop has turned off. Let me turn on again. I think we don't need to turn on it, we can just check it. Yes, so pin number 1 is 3.3, and pin number 2, did you see that 1.6 volt? If you check on pin number 3, 3.2 volts, so that is correct. That is a power button signal. Pin number 4 is ground. So we are getting 1.5 volt for lead switch. So we should have 3.3 volts. So this is the problem for getting a white display without a picture. So let us focus on the schematics and understand how this is happening on the motherboard if there's a problem on the lead switch here. Okay. Okay, so this is the power button connector of this motherboard here. So you can see JPWR. So pin number 1 is connected to 3.3 volt, and pin number 2 is the lead switch line, and pin number 3 is the on-off button. So and pin number 4 is connected to ground. So if you look at these two signals, they have hash symbol at last. So hash symbol means so they are active low. So you should get 0 volt on this line in order for the EC chip to understand that the lid has closed. So for example, when the laptop is open, you will get 3.3 volt on the lead switch line, and when the laptop is closed, you will get 0 volt on this line, and then the EC chip will understand that the laptop has closed and then it will do some actions like turning off the display and taking the computer into a sleep mode. So if the lit switch goes mad, it will send a lesser voltage even though your laptop is open, like a 1.5 volt on this motherboard, and I have found 0.6 volt, 0.8 volt, something like that, below 3.3 volt. So even though you get a higher voltage than 0 volt, the switch will immediately do some actions like turning off the display and taking the computer into a sleep mode. But on this motherboard we are getting a weird case, so it's an unusual, and we are getting the backlight and we are not getting the images on the screen. So I don't know how does the EC chip tells the CPU that to turn off the display, to turn off the image to the display. So we need to find that. So we can just go to the SIO page, the EC chip page, and find is there any communication. So there will be some lit out function from the EC chip to the CPU. So if there is any communication with that, then we can see and confirm that the EC chip is telling the CPU to stop sending the video signal to the display. Anyhow, I will just find and search it. Yeah, it's here. Okay. So this is a pull-up voltage from 3.3 volt EC. Okay. So this is an input signal on pin number 115. Yes. I need to find a lit out. So not there. Okay. Not there. Yeah. Let me check lit switch. So you can see they have written remove EC lit out function. So the lit out function is not there, not activated on this motherboard. Okay. So my question is, how does the EC chip tells the CPU to turn off the display? I don't know. What signal it can use to tell the CPU to turn off the display? And also, if you look at this point here on 105, this is EC backlight off signal. So this signal is active even though we are getting 1.5 volt at this pin. Okay, so EC chip is not sending 0 volt on this line, but it is telling the CPU to turn off the video or the image. Okay, so I don't want to dive deeper into this one here. And here we have the enable backlight signal. Wait a minute. So here we have backlight off signal. Okay, and here we have the enable backlight signal. Both of them are output. Yes. Okay, let me check this one. Where it goes. So we don't have this circuit here. Okay. Oh yeah, this is connected to this point here as EC touchscreen backlight off. Yes, it's going to straightly to the display connector here as display on-off signal. Okay, so the display on-off signal is done by the SIO in this motherboard. An inverter PWM signal to control the brightness. This comes from the CPU, from the LVDS section. Okay. So this is the control signal for the backlight on off, but this is not actually working on this motherboard. So the backlight is active. That's why we are getting a white display. Fine. Okay, so now let me move on to the EC chip and find the backlight enable signal. Another backlight enable signal is going to CPU, I think. Let me check which one. Yes, this is the backlight enable signal. Yes. So wait a minute. So this looks like an output signal. Okay. From the EC chip going to this point. Okay. And here also they have mentioned as an output signal. I don't know. So this is an output signal. Okay. From the EDP backlight enable. Okay. Fine. So this is an output signal that goes to the EC chip. And then with regard to this signal, then the EC chip will turn on the backlight. Okay, that's fine. So once the EC chip gets a signal on this point, it will turn on the backlight. So on this point you will get 3.3 volt on backlight off, EC backlight off, then you get 3.3 volt at this point. So we can say initially the backlight is controlled by the CPU. Okay, just leave it alone. So we can just focus on the lid, I mean the power button board, and we can repair it to work. Okay. Okay, so this is the power switch board, and here we have the power button, this one here, and here we have a component, and on the other side here also we have a component. So these two components look similar. So how to find our Hall transistor? So if you look at the location number on this point, they have written as U1. So U means it's an integrated circuit. And on the other side, they have written as D1. So D means referred to as a diode. I'm sure Hall transistor is not referred to as a diode. So most probably, this should be our Hall transistor. So if the Hall transistor fails in this power board here, we don't need to replace the entire power board. We can just replace the whole transistor from another spare power board and fix it here. So if you look at the pin arrangement of this Hall transistor, so this pin is connected to ground straightly, and here we have the lead switch pin that is straightly connected to the EC chip, and this is connected to the VCC, which is 3.3 volt line. So when the magnet comes closer to this transistor here, it will connect the ground to this point here through the magnetic field. And then the magnetic field disappears when the magnet goes far away. Then it will connect VCC to this point, I mean to VCC to this point here, and we will get 3.3 volt. So this is how the Hall transistor works. So now we can replace another Hall transistor and test with the magnet whether everything is working fine. Okay. And also, in order to confirm if this is the Hall transistor, we can check the continuity from ground to this point here. So continuity mode, okay. To this point, yes, we have a continuity. So this is connected to ground. Turning out on the other side, checking this point, checking to ground. Yes, this is also connected to ground. So we can't compare with that. So we need to refer to the location number. So they will confuse us. Don't check with ground on this point. So they are both connected to ground. Okay, right. So let us replace another one and check it. Okay, before removing the transistor, let me check the impedance value from the ground point to lead out point to the lead switch point. So let me check it. Yes, we are having 0.9 diode drop value. Okay, and on this side we have over limit. Okay, so this is over limit, and on this side we have 0.9. so this is far enough, but still it is low, I think. So we can replace another transistor and check its value whether they are correct or whether they are greater than 0.9 diode drop value. I have here the power button board of the Dell laptop, and also we can see here we have a component looks like a transistor, the Hall transistor, and we don't have any other component on this motherboard except this one. Okay, so you can see it is written as U1 here also. So we can confirm that U1 is the Hall transistor on this on this power board here. Okay, so we need to replace this Hall transistor in this motherboard and check whether they are working fine. Now let me check the impedance value on this one and compare with the readings that we saw on this motherboard here. Okay, so we have 0.6 die drop value. Okay, which is more lesser than the other one. Okay, so if I probe on the opposite side, I'm getting a higher reading. Yes. If I probe on this way, so I'm probing the positive probe to ground, I'm getting 0.6 die drop value. The same reading on this point, on this transistor, yeah, I'm getting 0.5. If I turn to the other side, 0.9. Okay, the same reading here. Positive probe on ground, I'm getting 0.6. Opposite way around, I'm getting over limit. So I think this is healthier than this one here. Okay, so I can try to replace this one on this point on this motherboard and check whether it is working. Okay, so that looks fine. Okay, so let me check the diode value again from ground to lid out. Here 0.5. Okay, on the opposite side, yeah, now I am reading 2.2 diode drop value and it's increasing. So now they are correct. So the value looks good. So this Hall transistor is good actually. Okay, anyhow we can check it by fixing on the motherboard. Okay, so now I have connected the power button board with the motherboard here. So now let me connect the adapter and check the voltage on the lead switch. Checking the voltage, so we should read 0 volt because I have now closed the laptop, so the lead should be 0 volt. Okay, checking the voltage, 3.3 volt. Wait a minute, that's wrong actually. We should have 0 volt. Power button connector, yes, power button signal is okay. Okay, let me check whether we have a magnet there. Oh, we don't have a magnet here. It's missing, I think. Yeah. Okay, no problem. I'll use another magnet and check it. Okay. So I have a small magnet here, so I can use that. Look at the multimeter. Bringing the magnet close. Yes, I'm getting 0 volt, 3.3 volt, 0 volt. Okay, now that's working fine. Now let me turn on the laptop and see whether we are getting a display with images and backlight. Yes, we got the display. Now everything is working fine. Let me turn on again. So actually this display is not good, that's why it's not showing correctly. Okay, now we got the display, everything is working fine. So the images are there. Okay guys, so thanks for watching.